Okay, so today is about chapter 3. So again, some of the subtopic here you have learned already before, so should be not a problem to you lah. Okay, so chapter 3 is about determinants. Okay, so here are the list of subtopics. The first one is just introduction. So basically just introduce like to refresh back what you have learned about determinant before. And then second one is the properties of determinants, and then after that cofactor expansion. That one you learned already, I think. The fourth one is the inverse of a matrix, and the last one is a Cramer's rule. Okay, so we continue with the introduction. Okay, so basically in this chapter we only consider the square matrix only. So square matrix only. So because only square matrix we can find determinant. Other than that we cannot find the determinant. Okay, so the notation of the determinant is either you write determinant dt bracket a, or you just write dta, or you can just the absolute of a. Okay, so two straight lines. Now if you only have one by one matrix A11 only, meaning only one entry, then the determinant is the entry itself is the A11. If we have a 2 by 2 matrices, okay, so to find determinant, so this is the formula. So basically it's just a A11 multiply with A22 and then minus with A12 multiply A21. Okay, so there's a minus sign here. So this product minus this product minus with this product. Okay, so an example is this. So this is one of the example. Okay, given A is this matrix, find the determinant. So you just take 2 multiply with 5. Okay, and then minus negative 3 multiply with 4. So you have that one. So end product or the final value is 22. Okay, so that's for 2 by 2 matrices. If 3 by 3 matrices, okay, so this is the formula. Or what you can do is you just write down your matrix here. So this is your matrix, and then you repeat the first 2 columns here at the back. Okay, and then you do the multiplication according to the lines here. So the red color is you multiply all these 3, and then you plus multiply all these 3 plus multiply all these 3, and then the blue color is the same, it's a multiplication, but is the minus, and then you minus with this, minus with this, minus with this product lah. So that's why you have 2 plus sign, and then you have 3 minus. Okay, so normally for 3 by 3 matrix, so this method is the easiest one lah. Okay, mine suddenly don't have, now got it. Okay, so you can hear me? Good. Okay, so one example is this. Given A, so basically you just copy down the matrix. Two, 1, 3, 3, 1, 2, and then you repeat the first 2 columns. 2, 1, 1, and then you do the product lah. So 1 times 1 times 2, so you get this, and then you plus 2 times 3 times 3, so you have that, and then Lastly, 3 times 2 times 1, you have this, so another plus. And then after that, you do the other one, the minus 1. The minus 1 is this line, 3 times 1 times 3. Remember, it's minus, so you have this. And then minus 1 times 3 times 1, so you have that. And then minus 2 times 2 times 2, so you have this. And then simplify, you get 6 for the answer. Okay. Now, next is the property of the determinants. I'm not sure whether you learned this before, but we just go through. Okay, so the first property of determinants is that if A is a matrix, then determinant of A is equals to the determinant of A transpose. So, for example, here we have a matrix A, and then this is the A transpose. Okay, so for the transpose, remember, column become row, row become column. Okay, it's either way lah. Okay, so if you calculate the determinant, okay, so this is the determinant, you can go home, check for yourself. So the determinant of A is 6, and then it's the same as the determinant of A transpose, because these two, if you look at it closer, they are both the same matrix, so then you have the same determinant. Okay, so that's the first property. The second property, if a matrix B results from matrix A by interchanging two different rows or columns of A, then determinant of B is equal to negative determinant of A. Okay, so meaning if you switch or if you swap any two rows, any two columns, then the determinant for the new matrix is equals to negative determinant of the old matrix. Okay, so let A is given by this. So if you interchange row 1 and row 2, so this is our matrix B, new matrix. So if you calculate the determinant, so determinant for B is negative 7, and then determinant of A is 7. So determinant of B is equal to negative determinant of A. So you just remember, whenever you do swapping two rows or column, you need to add a negative sign for the determinant. Okay. The third one, if two rows or columns of matrix A are equal, then determinant of A equals to 0. So for example, here, if you look at the matrix, row 1 is equals to row 3. Okay, so therefore we can straight away say that determinant of A equals to 0. So if you want to prove, then you go home and do.
Any two zeros, sir?
No. Any two columns or row that has the same value. You see, the row 1, 1, 2, 3, row 3, 1, 2, 3. So you straight away say that the determinant is equals to 0. You can go home, you can, after class, you can check, not go home. Boleh? Faham, Dennis, Nelson? The rest, okay? Faham?
Okay.
It applies to column as well. Yes, correct. So let's say I have a matrix A, 1, negative 1, 1, 2, 0, 2. And then column 3, you have the same, 1, negative 1, 1. So determinant A is equals to 0. You can check after this. Okay? Okay. This is important. All the properties you need to remember, because after this we will use all these property to calculate determinant. Okay, next is if a row or column of A consists entirely of zeros, then determinant A equals to 0. So for example here, row 3 all zeros, so determinant of A equals to 0. Okay, This is very simple to understand. If you remember our method to calculate determinant just now, so if this is determinant, you repeat the first two column, then you do the product. You see, each of the line you need to multiply with 0, 0, 0, 0. Then that's why you get 0. Always get 0. That's why at the end, determinant equals to 0. Okay. So that's that, and then the new one. If a matrix B is obtained from A by multiplying a row or column of A by a real number k, then determinant of B equals to k determinant of A. Okay, so for example here, this is our initial matrix, and then if you perform the row operation, this is the row operation where you multiply 2 to row 1, then you have a new matrix, and then after that you multiply 3 to column 2, you have a new matrix B. Okay, so to calculate the determinant for matrix B, it works the other way around. It works like a factorization, but it's not scalar. It's not like a scalar multiplication, but because this is for determinant, so it's like this is new matrix B. Remember our new matrix B. So this is actually like you factorize 3 from column 2. Okay, then you have the second matrix, and then after that you multiply, you factorize 2 from column from row 1. Okay, so at the end, to calculate the determinant, so 2 times 3 you get 6, and then this one is 1 times 4 minus 1, so you have this. So determinant equals to 18. So this is like a factorization, but it's not entirely like factorization. The concept is there. Okay, Ole? Okay, good. Okay, next is another row operation. Okay, so if matrix B is obtained from matrix A by adding to each element of R row of A k times the corresponding element of S row, then determinant A equals to determinant B. Now, this wording is quite long. Maybe you don't know or you cannot imagine. So you just look at our example here. If you have this kind of row operation, this type of row operation, remember we have 3 types of row operation in the last chapter. So this is the third type. This is type 3. Type 3. If you have this type of row operation, the determinant of both matrices is the same. No changes. Okay. Okay. And then next, this is the last one actually. So if a matrix A is an upper or lower triangular matrix, then the determinant is the product of all the diagonal elements. Okay, so for example here, this is the upper triangular. Okay, then the determinant is the product of the entries along the main diagonal. Okay, so you have this. Okay, so to simplify, so just a summary. So all the properties discussed so far are useful in evaluating determinants, especially when the size of a matrix is big. Okay, especially 4 after 4, 5, 6, and so on. Okay, so what we need to do is you transform the matrix by using elementary row operation or column operation. Again, in our course, normally we just focus on row operation. To a triangular matrix. Okay, you transform a matrix into a triangular matrix. Then after that, you use this property to find the determinant. Okay, so that's why the triangular matrix is important here. Now this method is known as the reduction to triangular form. Okay, remember the name of the method, because in the exam we will give you the name. Then you need to use this method lah. You cannot use the one that we mentioned in the introduction. If you use that, then 0 mark lah. Okay, so this is the summary. So if you have this type of row operation, then the effect on the new value of the determinant is this. You just multiply C to the old determinant. If you have this type of row operation, the determinant of a new matrix is equals to the determinant of the old matrix. Okay. If you interchange two different rows, then you just need to add a negative sign. Okay, so this is the effect on each type of row operation that we have mentioned in last chapter. Okay, so let's go to the example here. Compute the determinant A where the matrix A is given by this. Now, I need to remind you that this is just one type of the solution. It does not necessarily must be like this, but this is one of the solution. You can, after class, you can try your own solution, but make sure the final determinant is the same. So remember to use the correct notation for a determinant. It's a true straight line, because normally in exam, students still write like this. Okay, this one, the symbol is wrong. It must be two straight lines. The determinant is equals to, okay. Now the first here is we use, the first step is we use this property, the first property. Okay, so it works like a factorization, like you factor out 2 from row 3. Okay, so 2 is the common factor for row 3. So I want to factor it out so that I have 1, 2, 3. Because remember, our aim is to reduce the matrix into a triangular matrix using our row operation. So since we always get used to the leading one, so that's why we keep to 1 here lah. But of course, you can use other value. It's not necessarily must be 1, but to be convenient to you lah. I don't want you to confuse. So we stick to 1 here. Okay. We stick to 1 here. So after that, because we want to perform a row operation to reduce into triangular, so we swap row 1 and row 3 so that we have 1 at row 1. So when you do swapping, remember you add a negative sign here. Okay. Then after that, I want to make this to become 0. Because remember, our aim is to change this to a triangular matrix. So to do that, we need these two row operation. Okay, so if you apply these two row operation, then you get 0 here, get 0 here, and then a new value for row 2, row 3. Okay, and remember, when you do this row operation, no changes to the determinant. The determinant value is still the same, no changes. Now after that, I want to make this 0. Okay, so that's why I have another row operation like this. And again, when you apply this type of row operation, no changes to the determinant value. Okay, it's still the same. So at the end, so this is our triangular matrix. So you have 0 here, you have 0 here, you have 0 here. So the determinant value is the product of all the entries along the main diagonal. So that's why you have a -2 times 1 times -8 times -30/4. So simplify, you get -120. Okay. So this is one of the example. Again, this is just one solution. You can get another solution depending on what row operation you use. Okay, next example is we have a 4 by 4 matrix. Okay, so now the matrix is getting bigger. So again, to find the determinant, make sure you have a correct symbol. Okay, so copy down the matrix. Now, again, we can always factor out 2 from row 1. That's why you have this, and then the new for row 1. Okay. So after that, you need to change this to 0, 0, 0 using row operation. So then we have this 3 row operation. So that we have 0, 0, 0 here. Okay. Now after that, I want to make this 0. So we have new row operation. So to make this 0. Okay. Now remember when you apply this row operation, no changes to the determinant. It's still the same. So the last step is I want to make this 0. And using this row operation, so we have this 0. So again, no changes to the determinant value when you apply this type of row operation. So finally, to calculate the determinant is the product of all the entries along the main diagonal. So you have 2 times 1 times 3 times -6 times 1. So equals to -36. Okay. Boleh? Any question?
No, sir. So far, very clear, sir.
Okay. Then after that, we'll continue on. So a few other properties of determinant. If A is a square matrix, then A is non-singular or invertible if and only if determinant is not equal to 0. Okay. If determinant 0, then A is singular or non-invertible. I think this one I mentioned in chapter 1 already. And then the second one, if A is a square matrix, then AX equals to 0 has a non-trivial solution if and only if determinant A is not equal to 0. Non-trivial solution means X is not equals to 0, 0, 0. Okay. If 0, 0, 0 is a trivial solution, non-trivial means it's not 0, 0, 0. Okay. The third one, if A and B are a square matrix, then determinant AB equals to determinant A times determinant B. Okay, so this is one example here. So given matrix A, matrix B, so then you can calculate determinant A is equals to -2, determinant B is 5, and then if you find AB, you do the matrix multiplication, you will get this matrix. And then from here, you can calculate the determinant, okay, equals to -10. So this is actually equals to this times this, okay. So determinant AB equals to determinant A times determinant B, okay. Now, this is another method of finding determinant. I think you learned this in your high school as TPM or matriculation. But we go through. The first one is we need to know what is a minor of Aij. Okay, so this is the definition of minor. So let A be a square matrix, and then Mij is the minus 1 times n minus 1 submatrix of A, obtained by deleting the I row and the j row of A. Then the determinant Mij is called the minor. Okay. Then after that, the definition for cofactor, the cofactor Aij of element Aij is defined as this formula. Is basically you have a negative 1 to the power of I plus j times determinant Mij. So this is basically the minor lah. The minor. Okay. Now it's quite difficult for us to remember the formula because when we have too many formulas, it's quite difficult to memorize. So one way for us to remember this, the sign here is the sign is actually based on the position Ij of a matrix. So basically, if you have a 3 by 3 matrix, then you always start with plus and then minus, plus, minus, plus, minus, plus, minus, plus. If you have a 4 by 4, again you have a plus first. Always start with plus sign and then negative, plus, minus, and then plus. You have plus, minus, and so on. So if you remember the position here, then you don't need to remember the formula here. You just need to remember the minor here. Okay. Now, example here, let A is this matrix. Find this one is a minor mi2, m23, m31, and then the cofactor a12, a23, and a31. Okay. Now, determinant m12 here is obtained by deleting row 1 and then column 2. You look at the number here, subscript. 1, 2 means delete row 1, delete column 2. Then you have this matrix. Okay. So then you find the determinant is just this multiply and then minus with this. So you get negative 34. And then the second one is determinant M31. Again, you look at the subscript. So M31 is obtained by deleting row 3 and then row 1. So this is what you have here. Then you have, you have this. Okay. And then the second one, M23. So is delete row 2 and column 3. So you have this matrix. Okay. And then the A12, A23, A31 is basically the you just apply the formula here, okay, to get the plus or minus sign. So that's why you have this. So and then you apply the determinant, the one we obtain here. Everything we obtain here, you just put it here, and you get the cofactor. Okay. And then the next one is to find the determinant. Using cofactor means you expand along one of the row is row I, then the formula is this. Now basically, I know you don't know what is the meaning of the formula, so I'll just go straight to the example to explain to you how to use this formula actually. Okay. Now, to find the determinant using the cofactor expansion, so remember today we learned two ways of finding determinant. So I repeat again, the first way is this. require reduction to a triangular form. So you need to remember the method's name. Second one is the cofactor expansion. Okay, this method. Okay, so how do we apply the this cofactor expansion? What you do is we need to do expansion along row or column. Now, which row or which column? So the rule of thumb here is if there is a 0 in your matrix, you choose the row or column that has the largest number of 0. Okay. So for example here, our matrix here. So we have 3 zeros here. Okay. So you either choose row 3 because row 3 you have 2 0. Okay. Or you can choose column 2 because column 2 also got 2 0 here. Now let's say if in your matrix no 0 at all. So what you do is you pick any rows or any column at your convenience. Normally for me, I will choose the one that has the smallest integer. Okay, not the big integer, the smallest one. Okay, now let's say in here I choose third row. I choose third row. I choose third row means I focus on this. You take this to do your cofactor expansion. Now for the cofactor expansion, remember the plus minus sign here is important. So that's why here you always start with plus and then minus and then plus. Because we want to expand along row 3, okay, so you just do the plus minus sign for the row 3, not all the entries in the matrix. So plus minus plus minus. So you have a minus here. So what it means by the expansion is that, okay, you take the first element plus 3 and then you delete row 3 and then first column, and then what's left here is your submatrix. So this is your submatrix. Okay, and then after that I need to clear this first. So remember we have a sign plus minus plus minus. After that you continue with the second one. It's actually minus 0. You have a matrix, submatrix here. Now because 0 times any submatrix will always is 0, so we don't put it here. And then after that you continue with the third one, also plus 0, a submatrix here. Again this one always 0, so we don't write it in our solution. Then after that finally we have a fourth value here. So fourth is you have a negative sign here. So you have a negative, and then negative 3, so you have a negative 3. Then after that you delete row 3 and then delete 4 column. Then what's left is your submatrix. So this is your submatrix. Okay. Now, so this is a 3 by 3 matrix. Okay. So because the method say we need to use the cofactor expansion, so you need to do the same thing with these two matrices as well. Okay. So let me delete the scratches here. Okay. Now first we do for the first column, not first column, first matrix. Again you pick the row or column that has 0. Okay, so since column 1 or row 3 has 0, so let's say now I choose first column. Okay, so again you do plus, minus, plus sign. Okay. So then from here you have 3, and then first you open out a very big bracket here for our cofactor expansion for this matrix. So here you have 2. The first one is a plus 2, so you have positive 2, and then you delete this row, delete this column, so you have 2, so 1, 3, negative 2, 3, and then minus, because you have minus here, and then 2, minus 2, and then delete this and delete this, so you have negative 3, 4, negative 2, 3, and then the last one is 0, so 0 no need to write, it's actually plus 0 here. Okay, so that's for the first part. Okay, first part of the matrix. So that's how I have this. Okay, I have the first part here. Yeah. Now the second part. So for the second matrix, okay. For the second part here. So negative 3, so you have plus 3, and then you open a big bracket. Okay. Again, choose a row or column that has many 0. Okay. So let's say I choose which. Let's say I choose row 3. Okay, I choose row 3. Again, you do plus, minus, plus sign. And you have minus, you have plus. Okay. So the first one is plus 2. So you have 2. So delete this and delete this. You have 2, 2, negative 3, 1. And then the second one is negative 0. So 0 times anything is always 0. So you just write negative 0, or you don't write at all. And then third one is negative plus negative 2. So it's negative 2. And then delete this, you have negative 1, negative 4, 2, 2. Okay, so that's why we have the second part. Now after that, you just do the matrix, the determinant, how to find determinant for 2 by 2 matrix is this minus this, this minus this. So that's why you have this 3 times say this is 3, this is 3 minus, so plus 3 minus 6 plus 6. So this is 9, and then this is negative 9 minus negative 8, so plus 8, negative 1. Okay, so 2 times 9 is this part, minus 2 times negative 1 is this part. The way they type this slide is the other way around. Don't be confused later on. And then this times this minus this times this, so it's 2 minus 6, so plus 6 is 8. This one is 8. So you get 2 times 8. And then this one 2 minus negative 8. So 2 plus 8, 10. So this one 10, you have this. So simplify, you get 48. Okay? Boleh? This is the cofactor expansion. Boleh ya? I hope you're clear lah. If you still remember what you learned, then it's good. If not, then hopefully you're clear. Now, another example is that, okay, calculate the determinant of the following matrix. Okay. Now here again, you choose the row that has the 0. Okay, now our answer here is we choose the last row. Okay, choose the last row. And then after that, do the plus, minus, plus, minus, plus. So the first one is plus 2. So you have plus 2. Delete, delete. So you have this matrix. Okay. And then negative 2, negative 2. Then delete, delete. Okay. Delete this. You have this matrix. Simplify, you get 24. Clear? Okay. So that's the cofactor expansion for finding determinant. Okay. Now next is using the cofactor to find the inverse of matrix. Now before finding the inverse, the first thing you need to find is the adjoint A. Now the adjoint of matrix A is the matrix whose ij entry is the cofactor A ji of AJI. Okay, is a so basically this is the matrix adjoint, and then the element is the cofactors. Now the one thing you need to take note here is you look at the subscript here. Normally when we write a matrix, we write A11, A12, A13, and then A21, A22, A23, A31, A32, A33. So for a 3 by 3 lah. But for adjoint, adjoint is the transpose. You see the A11, A12, until A1n. Okay, and then A21, A22, A2n. So you need to be careful here. When finding the adjoint, you need to do the transpose. So in other words, here you see the remark there. The adjoint of A is the transpose of a matrix of cofactor. You can write like this, but then you must put the transpose sign here for adjoint. Okay, because from experience, many students they're confused. They don't put transpose, and then they think this is the adjoint, which is wrong. Okay. Now, this is the example of finding the adjoint given a matrix A. Yes, Rahul, you raise a hand.
Sir, the transpose meaning switching rows with columns, right?
Yeah.
All right.
Okay. So to compute the adjoint, first because you see the formula, the adjoint for formula is all the cofactors. So one way is you find all the cofactors. Okay. One by one. So meaning for A11, you delete column 1, row 1, so that you have this matrix. And then for A12, you delete row 1, column 2, then you have this matrix. And then you You need to be careful. For adjoint, you have a plus minus sign here. Plus, minus, plus, minus, plus, minus. Okay. It's not minor. If minor, you ignore the plus minus sign. But for cofactor, you have a plus minus sign. Now this is one way for you to do. You calculate the cofactor one by one, and then after that you just put in your matrix like this. You collect them in the form of matrix, so then you will get the adjoint like this. Now this is one way. Another way is where I see many students, they are quite lazy actually, so they put everything together at one go. So what you do is they always, I don't have much space to write, so I write here. They write adjoint A is equals to matrix, a big matrix. What they do is they straight away do the calculation here. So plus A11, so meaning they straight away delete row 1, column 1, 6, 0, 2, -3. And then the second one is A12. A12 is negative, and then you delete row 1, column 2. So you have a negative 5, 1, 2, -3. And then third one is plus. You delete row 1, column 3. You get 5, 6, 1, 0. And so on. Okay. They straight away put everything in matrix form, which is quite good for some. Okay, you don't get confused. Okay, like this is okay. Okay, and the rest you just fill in. Okay. Another example for finding adjoint, again, is the same thing. You calculate each one of them separately, but you need to be careful with the plus, minus, plus, minus, plus, minus here. And another way is like I showed just now, adjoint A is you put everything in a big bracket, so plus -4 -1 to 5, then minus, and so on. Okay, so that's the adjoint. Okay, so once you have the adjoint, then after that we can calculate the inverse lah. Okay, now before that, there's one theorem for adjoint. Okay, if A is a square matrix, then A times adjoint A is equals to adjoint A times A is equals to determinant of A times identity matrix. For example here, so we have the matrix A, and then if you times this is A, and then this is the adjoint A. You can double check after this for your exercise to check whether this is the adjoint A or not. Okay, is equals to, this is the determinant A, and then this is the identity matrix I3. Okay, or the other way around, adjoint A, this is times A, then you get same, this is the determinant A, and this is identity matrix. Okay, now next is the formula for finding inverse of A, okay, using the adjoint. So the matrix, the inverse of A is adjoint A divide by determinant. Okay, so find the matrix A, the same matrix that we show here. So this is actually a join A. This is a join A, and then divide by determinant. Okay. Now, the final answer for the inverse matrix. Okay, so you need to multiply this into the matrix. You need to do the scalar multiplication. Okay, so you need to keep your final answer in this form. This is the same thing in your STPM. For the inverse matrix, you need to write your final answer is this. Otherwise, if you stop here, you will lose marks. Okay, because your final answer is this. Okay, so that's the inverse matrix using can you stay like that without simplifying? You just multiply in. Not much time needed. Ole, Lewis. Okay, the final subtopic. Kramer's rule. I'm not sure whether you learned this before already. Because I can't remember your syllabus, your STPM syllabus and matriculation. But Kramer's rule is very easy. It's a very easy rules. This is to solve a linear system of n equation with n unknowns. Okay, so let's say you have a system of linear equation. If the determinant is not zero, then the system has a unique solution. So to find the value for each of the unknown x1, x2, x3, and so on until xn. So this is the formula. X1 equals to determinant of A1 divided by determinant of A. X2 is the determinant of A2 divided by determinant of A. And so on until xn, determinant of AN divided by determinant of A. Now if you look at the formula here, the similar part is this denominator is always divided by determinant of A. Now determinant, the matrix A here is the coefficient matrix. So A is the coefficient matrix. So meaning all this value, all the A's here in the linear system. Okay, that's determinant of A. And then the different part here is here is this determinant A1, A2, A3, and so on. So the matrix A1, A2, A3, and so on is the matrix obtained from matrix A by replacing the i-root column of A by B. Okay, meaning what does that mean? Meaning, so if let's say our A, if consider a 3 by 3 linear system, you have A11, A21, A31, A12, A13, and then A22, A23, A32, A33. Now the matrix A1 is obtained by you replacing the first column with B. Okay, so meaning your A1, the first column is B1, B2, B3, and then the second and the third column is the same as matrix A, A12, A13, A22, A23, A32, A33. Okay, that's for A1. If A2 is you replace the second column lah. So second column is B1, B2, B3. And then the first one and the first column and the third column is the same. A11, A21, A31, A13, A23, A33. This is the third column. The same thing for A3. A3 is you place this with B. Boleh? Okay. So
Boleh.
we go to example. It'll be easier to understand. Now solve the following linear system using Cramer's rule. Okay, so first you find determinant A. So remember A is the coefficient matrix. So -2, -2, 1. So 3, 2, -1. So you have this. Then -1, -1, +1. So you have this. So find the determinant. Now for Cramer's rule, if 3 by 3 matrix, it's up to you whether you want to use the cofactor expansion to find the determinant, or you can use the one that I mentioned in the introduction part. To me, I prefer the introduction part one. It's easier. Okay. If you want to use cofactor, it's okay. If you want to use I think nobody use the method, the reduction to the triangular matrix, the raw operation one. Is either you use the cofactor or you use the one at the introduction part. Okay, so that's the determinant for matrix A. Now so for x1, remember you need to replace column 1, the first column for our matrix A, with this. Okay, so that's why the column 1 is matrix B, and then divide by determinant A. X2 is you replace the second column with matrix B. First column, third column is the same as A, and then X3 you replace the third column. First column, second column is the same. Okay, then you simplify, you get 2, 3, 4. That's the Cramer's rule. Now another example is this. So this is the final example, I think. Okay, so first you find the coefficient matrix. Okay, find the determinant. Then x. So now we have x, y, z. Okay, so we have x. X again, you replace the first column with this, and then the y is the second column, z is the third column. So the rest is the same. You do the arithmetic, find the determinant, and then do the division. Now the last one is given the following system of equation, find the value of z. Okay, so you need to find z only. So again, for Cramer's rule, you always need to find determinant of A. After that, to find AZ. Okay, so determinant of AZ is you just replace the third column with this. Okay, then the Z is this. Alright, so that's the end for chapter 3. Any question? No. Before we end, I just recall, I need to remind you something here. Because many students make mistake here. Now this method here only applies to 3 by 3 matrices. Okay. not 4 by 4 or 5 by 5. Okay, because I saw some student when you have a 4 by 4 matrix, he also applied this method, which is wrong lah. Dia multiply 4 kali and then minus 4 kali. Okay, boleh? Okay, any question?
Hello, sir.
Yep.
So just now you told the conventional method is only for 3 by 3. So 4 by 4 is you use the cofactor expansion or the else.
Yeah,
then.
yeah, correct. That is correct. 4 by 4, you need to use the one we learned today. Any other question? Boleh? Then I'll stop sharing the slide. I will
Sir,
read. Yeah.
sorry, so the assignments will be released next week, is it?
Yes.
All right.
We will follow the weekly schedule. Don't worry. If not, then I will. If the assignment is still not out by next week, you let me know. I will inform course coordinator lah. Course coordinator is the Dr. Izatul lah. I will inform her. And never mind, I will remind her again this week later on.
All right, sir. Thank you, sir.
Okay. Any other question? If not, then if you already scan QR, then you leave. Take care. Stay safe. See you next week.